Welcome to the Deep Dive. Today we're going to crack open this deep learning tuning playbook. It's basically like a masterclass in, getting the absolute best performance out of your deep learning models.
Yeah, whether you've been doing this for years or just getting started.
Exactly. So one thing that really stood out to me was this whole idea of like starting simple.
Right.
Building that solid foundation with your model architecture and picking the right optimizer. What makes that so important?
I think of it like building a house.
Okay, yeah,
You wouldn't start decorating before you made sure the foundation was strong.
makes sense.
And in deep learning, you have these kind of proven blueprints, like ResNet or, transformers. They've been tested and refined, so it gives you a really reliable starting point.
Okay, so you've got your foundation set,
Right.
but then you've got like a ton of different optimizers to choose from. How do you even know where to start?
Yeah, that's where the playbook gets super practical. It kind of points you towards these popular, well-established optimizers. Especially if you're newer to this, Adam, SGD, these are like the workhorses of deep learning, and they often just perform really well.
It's like finding the tools that just work.
Exactly.
So we're all about efficiency here on the Deep Dive.
Always.
And one thing I've always wondered about is this whole batch size thing. Is bigger always better?
Oh, that's a myth
Oh, really?
that the playbook completely debunks.
Okay.
Batch size is really more about speed than accuracy.
Interesting.
It's about finding that sweet spot where your training, runs efficiently, but you're not sacrificing performance.
So it's kind of like finding the perfect cooking temperature.
Yeah.
Too low, it takes forever. Too high, you burn everything.
Exactly. And the playbook even has this really clever algorithm to help you figure out what that ideal batch size is based on your hardware.
That's awesome. So we've got our foundation, our optimizer, batch size is dialed in. What's next? Where do we go from here?
So this is where the playbook gets into this iterative nature of tuning. The back and forth between exploration and exploitation.
Okay, those are some terms that get thrown around a lot.
Yeah.
Can you break those down?
Imagine you're searching for buried treasure.
Okay.
Exploration is scouting out the terrain, testing different paths,
Okay.
gathering clues. Exploitation is then using those clues to focus your efforts where you think the treasure's actually buried.
So in deep learning, we're exploring different hyperparameters.
Right.
And then we're exploiting that knowledge to fine-tune the model.
Exactly.
But the playbook warns about getting blinded by those short-term gains, right?
Absolutely, yeah. It's not just about chasing immediate improvements. It's about thinking strategically, like a chess player, planning moves in advance.
I like that analogy.
Each experiment, whether it's a success or a failure, teaches you something valuable.
And those lessons come through in the training curves, right? That's what the playbook says. Training curves are like a detective's notebook.
I love that. That's a great way to think about it.
They can reveal subtle hints about, overfitting, or if there's some instability, maybe even bugs in the code. What are some of those clues that we might be seeing?
Let's say you're looking at your validation error and it starts creeping up,
Okay.
but your training error keeps going down. That's classic overfitting. Your model's basically memorizing the training data, but it can't generalize to new information.
It's like a student who just crams for a test.
Totally. Yeah.
They might ace that specific test,
Uh-huh.
but they haven't really learned the material. What other red flags should we be looking out for in those training curves?
If those error rates are just bouncing all over the place,
Oh, okay.
especially later in training,
Yeah.
that could be a sign of instability. Maybe your learning rate is too high or your batch size is too small.
Like riding a bike way too fast down a bumpy road.
Yes.
You're going to lose control.
Exactly. And one technique the playbook mentions for smoothing things out is learning rate warm-up.
Okay, now tell me more about this warm-up. Did this involve yoga for our neural networks or something?
Not quite,
No.
but it's kind of similar.
Okay.
It's about gradually increasing the learning rate at the beginning of training,
Okay.
rather than just starting with a high value right off the bat. Think about warming up your car engine on a cold day. You don't want to just floor it right away.
Makes sense. Ease your model into it.
Yeah.
And the playbook also talks about gradient clipping.
Right.
What's that all about?
Gradient clipping kind of acts as a safety valve for your model.
Okay.
If those gradients, the updates to your model's weights, if they get too large, gradient clipping prevents them from going haywire and causing all that instability.
So it's like setting those boundaries to prevent your model from overcorrecting itself.
Precisely.
Interesting. Now, the playbook also delves into batch normalization. And This can be a really powerful tool, but the playbook also says it can be a bit tricky.
Yeah.
Why is that?
It's really good at improving performance.
Okay.
You know, it normalizes those activations within each layer of your network,
Yeah.
but implementing it correctly can be kind of complex, especially when you're training across multiple devices.
Yeah, I can imagine things getting messy when you're trying to like coordinate all of that across different machines. What are some of the challenges there?
Imagine you're trying to bake a cake, but you've got multiple ovens,
Okay.
and they're all set to slightly different temperatures. You might end up with like some parts are overcooked, some parts are undercooked, a very inconsistent cake. So we need to make sure those ovens are in sync to get a good cake, or in this case, a well-trained model.
Exactly.
What does the playbook suggest for that?
They get really in-depth.
Yeah.
They talk about techniques like ghost batch normalization.
Okay.
They stress the importance of like carefully handling those exponential moving averages.
That are used in batch normalization during testing.
So it's all about the details.
Absolutely. And, you know, speaking of complexity, the playbook also touches on multi-host pipelines,
Yes.
which take things to a whole other level.
That's where you're distributing the training across like multiple machines.
Right?
That sounds like a whole other beast.
It is. You get incredible scalability, but it also has its own set of challenges.
It's like conducting an orchestra.
Yeah,
Every musician needs to be perfectly in sync
exactly.
to create that harmonious symphony.
What are some of the things that can go wrong when you're in that multi-host environment? Synchronization is still a major hurdle, especially for things like logging, evaluations, you know, checkpointing. Imagine each section of the orchestra starting and stopping at slightly different times.
Chaos.
Total chaos.
The conductor's nightmare. So we need meticulous coordination to make sure those multi-host pipelines are running smoothly. What else should we be keeping in mind when we're venturing into this world of distributed training?
Random number generation.
Okay.
It's really crucial. Each host needs to be generating random numbers that are consistent across the machines, but also there has to be sufficient randomness within each machine.
So we need synchronized randomness.
Yeah.
That sounds almost paradoxical.
It kind of is.
Yeah.
But the playbook, you know, it gives you a lot of guidance on how to set up these multi-host pipelines effectively.
It seems like this playbook has really covered a lot of ground, you know,
It really has.
from those like fundamental choices
Right?
to these intricate multi-host setups. It's like a roadmap for navigating this whole world of deep learning tuning.
It really is.
And there's still so much more.
Oh, yeah, definitely.
This was just scratching the surface.
Absolutely. We've just touched on some key points here.
Yeah, and that's a perfect lead into the next part of our deep dive. We're going to be exploring the playbook strategies for optimizing training duration,
Right.
making the most out of those precious computing resources. Stay tuned.
Welcome back to the deep dive. Last time, we talked about setting up a solid foundation, choosing optimizers, and even dove into multi-host pipelines.
Yeah, we covered a lot of ground.
But figuring out when to actually stop training,
Right.
that's a crucial part of this whole deep learning puzzle.
It is.
And that's what we're going to be tackling today.
So we're talking about training duration, like how long we let those models cook. It's all about finding that balance between getting the best possible results
Right?
and not wasting time and resources.
Exactly. And the deep learning tuning playbook has this really interesting way of thinking about it.
Okay.
They break down workloads into two main types,
Okay.
compute-bound and not compute-bound.
Okay, break that down for me. What does that actually mean when we're talking about deep learning?
Okay. Imagine you've got like a super powerful sports car,
I like where this is going.
but you're stuck on a tiny little track.
Oh, no.
You can only go so fast, right? That's a compute-bound workload. It's limited by your hardware. So, training for longer or with more resources could potentially get you better results.
So it's like all this potential power, but you're held back
Exactly.
by limitations.
Now, imagine that same car on a wide-open highway.
Okay. Yeah.
Eventually, it's going to hit its top speed.
Right.
Pushing the engine harder isn't going to make it go any faster. That's not compute-bound.
Oh, okay.
Additional training, no matter how long you do it, how many resources you throw at it, it's not really going to improve performance.
So it's like hitting that plateau.
Exactly.
More effort doesn't equal better results. And figuring out which one of those your workload falls into, that's super important, right?
Yeah.
Because it dictates your whole strategy.
Exactly.
Okay, so let's say we're dealing with something that's not compute bound.
Okay.
How do we figure out that perfect training duration?
The playbook gives really simple advice here.
Okay.
Train long enough to get the best possible results
Mm,
without wasting steps. Avoid that excessive training.
right.
That might lead to overfitting.
Yeah, we've all been there.
Yeah, we've all done it. Training for way too long.
Mm-hmm.
Our model becomes a master of the training data, but then can't handle anything new.
Right.
The playbook actually suggests running your training for like a fixed number of steps
Okay.
and then choosing the best checkpoint based on your evaluation metrics.
So that best checkpoint, it might not necessarily be the final one.
Exactly.
That's interesting. So it's like watching a movie and choosing the most compelling scene, even if it's not the climax.
That's a great way to put it. And those training curves that we were talking about earlier, those are your guide.
Right.
If you see that validation error starting to climb
Okay.
while the training error keeps going down, that's a good sign that you should have stopped earlier.
They're whispering secrets to us, telling us when to stop.
Yeah.
So what about those compute-bound workloads
Right.
where resources are the bottleneck? What happens when we're limited by our hardware?
I think it's tempting to just train for as long as possible,
Yeah.
know? Try to squeeze out every little bit of performance. The playbook acknowledges that, but it says don't do that.
Okay.
Instead of one really long marathon training session,
Mm-hmm.
break it down into multiple rounds of tuning
Okay.
with progressively longer durations.
So it's more strategic,
Right.
like a series of sprints instead of one exhausting marathon?
Exactly. The idea is to get quick insights with those shorter runs, like scouting out the terrain and then refining things with longer, more focused runs.
I can see how that would be so much more efficient, especially when you're dealing with limited resources. Can you walk me through how those multiple rounds would work in practice?
Absolutely. Round one is all about exploration.
Okay.
You do these shorter training runs to identify the most promising model architectures,
Okay.
get a feel for which hyperparameters seem to be working well.
Gathering intel.
Yes. Once you have a better understanding of what's working,
Mm-hmm.
you move on to round two.
Okay.
Now, you focus on a few of the most promising configurations, and you train them for much longer.
So now we're sending in the elite forces.
Exactly. One really important detail here is that
Yeah.
you're going to want to adjust your learning rate decay schedule
Oh,
as you transition between those rounds.
makes sense.
You don't want to be stuck with like a tiny learning rate
Right.
when you've just given your model all this extra time to train.
Like slowing down just as you're hitting your stride.
Exactly. It's all about maintaining that balance between exploration and exploitation,
Right.
refining your strategy as you go.
This multi-round approach seems like a real game changer, especially for those of us who don't have, unlimited computing power.
It can be. You can use your resources strategically
Right.
and really maximize your training time.
And speaking of efficiency, the playbook also gets into optimizing your input pipeline.
Yes.
What is that all about?
The input pipeline, it's often overlooked,
Mm-hmm.
but it's super crucial
Okay.
for making sure you have a smooth, efficient flow of data to your model during training.
So it's like making sure the ingredients are all prepped and ready to go.
Exactly. A poorly optimized input pipeline
Mm.
can create bottlenecks
Yeah.
and really waste those computing resources.
So what are some of the pitfalls people run into?
One of the biggest issues is data that's not physically located near your training process.
Okay.
So think about it. If your raw materials are miles away from your factory,
Right.
transportation becomes a huge bottleneck.
Yeah. We got to minimize that data travel time.
Another challenge is like really expensive data pre-processing.
Okay.
That happens on the fly during training.
Okay.
It's like trying to chop vegetables while you're cooking.
Right.
It slows everything down. What the playbook says is do as much of that pre-processing offline as you can.
Smart.
Save those results. Be prepared.
Be prepared.
Yeah.
Love it. Any other tips for keeping that data flowing smoothly?
The playbook suggests using profiling tools
Mm-hmm.
to pinpoint bottlenecks. It's like having a detective
Oh, wow.
analyze your workflow
Right.
to find those inefficiencies.
And then once we've identified those, how do we address them?
One powerful technique is prefetching examples.
Okay.
So you're basically loading the data in advance,
Okay.
so it's ready to go when your model needs it.
That's efficient.
Think of it like having a sous chef who's always one step ahead,
I love that. Yeah.
always handing you the ingredients.
Right when you need them.
Exactly. Another good strategy
Mhm.
is to get rid of any features or metadata
Okay.
that you don't actually need
Right.
as early on as possible. Think of it as decluttering your workspace.
Less clutter, more focus.
Exactly. Now, For really massive data sets,
Yeah.
sharding your data files across multiple hosts can really help.
So we're breaking down that data mountain
Exactly.
into scalable chunks.
The Deep Learning Tuning Playbook gives you tons of guidance on how to do all of this effectively. It's really incredible.
It sounds like it. It's like they've thought of everything.
They really have.
From choosing that model architecture to fine-tuning that input pipeline. It's like a treasure trove of wisdom.
It is, and we're just getting started. In the next part of our deep dive,
Yes.
we'll get into the playbook's insights on evaluating model performance and all the complexities of batch normalization. Stay tuned for more deep learning enlightenment.
Welcome back to the deep dive. So we've spent the last 2 episodes digging into the deep learning tuning playbook. And we've covered a lot. We talked about like setting up that solid foundation,
Right.
optimizing those input pipelines.
Mm.
But how do we even know if all this hard work is actually paying off?
That's a great question.
Yeah, how do we evaluate the performance of our model?
Evaluating performance is all about understanding how well your model generalizes.
Okay.
Beyond that training data, think of it like taking a test after a semester of studying.
Right. You don't want a model that just memorizes the answers. You want one that can take what it's learned and apply it to new stuff.
Exactly. And the playbook really stresses that you need to create evaluation settings that closely mimic the real world.
Okay, so like test it in the wild.
Yeah, they talk about online evaluation, which is actually testing your model in a live production environment.
Okay.
And then there's offline evaluation, which is where you use dedicated data sets for testing.
Online evaluation seems like that's the ultimate test, but I imagine that can be tough to set up, right?
It can be, especially early on, so the playbook recommends doing these periodic evaluations during training.
Okay, yeah. So you're checking in on your model's progress at different points.
Exactly. You're getting those insights into how your model is learning, and you can spot any issues early on.
So those are like those little warning signs.
Exactly.
That can help you course correct.
The playbook recommends doing these evaluations at regular step intervals
Oh.
rather than like time intervals. It just gives you more consistent results.
So you want a standardized testing environment, just like in a classroom.
Exactly.
And the data you use for these evaluations, that's got to be important too, right?
Oh, absolutely. You want to make sure that data is similar to what your model will see in the real world.
Right. We don't want to give it a practice test that's totally different from the actual exam.
The playbook goes deep here, talking about building a strong evaluation pipeline, how to choose the right batch size, how to handle, imbalanced data sets.
It seems like they thought of everything.
And they really did.
Now, something we touched on before, the playbook circles back to batch normalization.
Right.
We talked about like how tricky it can be,
Mm-hmm.
especially with multi-host setups.
Mm-hmm.
How does batch normalization play into all of that?
Remember, batch normalization is all about calculating those statistics, like
Mhm.
the mean and variance, over a batch of data. And when you're training across multiple machines, you need to make sure those statistics are consistent.
We got to keep everyone on the same page.
Exactly. And the playbook, gets into the details of how to do that.
Okay.
They cover techniques like ghost batch normalization
Mm-hmm.
and how to handle those exponential moving averages.
It's amazing how they anticipate these things and then give solutions. Like they've been there.
They really have.
They've done that.
They also talk about experiment tracking.
Oh, yeah. Keeping track of all those experiments, super important, right?
It is.
For, going back and seeing what you did, being able to reproduce your results.
Think of it like a lab notebook.
Right.
Document every step of your process.
So it's not just about doing those experiments. It's about, like, building this knowledge base
Exactly.
you can go back to and learn from.
It's about taking a scientific approach to the whole process.
Well, I think that brings us to the end of our deep dive
It does.
into the Deep Learning Tuning Playbook. What a journey.
It really has been. This playbook is filled with practical advice that can help anyone master deep learning optimization.
It's like having a mentor by your side guiding you through every step.
It encourages you to really understand those core principles.
Yeah, not just making random tweaks,
No magic tricks, no secret formulas.
It's about becoming a deep learning detective.
Yes.
Carefully analyzing those clues and refining your approach.
Yeah.
And armed with this knowledge, I think we're all ready to tackle those deep learning challenges head on. So, to all our listeners out there, embrace the playbook's wisdom, experiment fearlessly, and keep pushing the boundaries of what's possible with deep learning. That's it for this deep dive. Happy tuning.